Today we want to start organic chemistry. Organic chemistry, or we can say carbon chemistry, is related to the biology and the biological compounds. First part, I start to explain the classification of the organic compounds. In the classification, we can say organic compounds can be divided into two groups. The first group is the acyclic, and the second group is the cyclic. Acyclic, as you see from the name, it is not cyclic. Okay? And it divides for two groups. Unbranched and branched. And cyclic also, in the main subdivision, can be carbo cyclic, okay, which has carbon and hydrogen, and heterocyclic, which has carbon hydrogen with nitrogen or oxygen or sulfur or some other elements, but mainly with this one. Also, I can divide cyclic from the other position, non-aromatic and aromatic. Okay, it is the first division about these two groups, acyclic and cyclic. Both of them have the same common properties. For both of them, we can have unsaturated and saturated. Unsaturated has a pi bond, and the saturated just has a sigma bond. And this group is the mainly, as you see, from this classification, we can classify also from the functional group. For example, acyclic from the unbranched or branched, or cyclic, we can have the different functional groups. Functional group. We can classify organic compound with the functional groups. Okay. I classify with the type of the component and type of the bonds. The first group is the hydrocarbon. They have carbon and hydrogen. Okay, this is the first group. The first one is alkane. Okay, it has a carbon and the hydrogen and saturated. Carbon and hydrogen and saturated. For example, C. If you see two carbons and I saturated with the hydrogen, as you see here, all of the bonds are sigma, and the name usually with the suffix A. For example, a ton. The second group is the alkane. Alkene has a one pi bond and one unsaturated bond. For example, if I draw these two carbon, minimum I have to put one double bond here, and I can put hydrogen or carbon for the rest. Okay? We studied just about the functional group. It is summary, and in the next lectures I can explain about the property of the alkane or alkene. Because as you know, functional group is the atom or group of the atoms or molecules which has the same characteristic physical and chemical properties. Okay, as you see here, one pi bond, and all the rest is the sigma bond, and the double bond is here, and the name is the suffix is inner. For example, ethene, but the common name is ethylene. Third group is the alkyne. As you see here, alkyne, it has a two pi bond and one sigma bond. It has a double bond. Has a double bond. But alkyne has a triple bond. Alkyne has a triple bond, which two is the pi and one sigma. For example, if I have two carbon, 2 pi and 1 sigma, for example, I put here, okay, and suffix is the ine, okay, is it ethine, but common name is acetylene. As you see here, it's very easy and very useful. Okay, hydrocarbon, maybe we can also have a mix of these and these. For example, it has a double bond and triple bond, or we can have more than two double bond, or two double bond, diene, triene, and all of them can be possible for the functional groups. Third group, okay, again we can have, for example, from this group also sub groups like diene, triene, okay, or mix of these two. We will study in the hydrocarbon lectures. The second group is the aromatic compounds. Aromatic compounds, it is a big lecture, we will study about it. But in aromatic compound, mainly we know it's the benzene ring, with the which accepts Hooke's rule, okay, and it is a cyclic. It has a 3 double bond. It can delocalize, and it has a resonance effect. It has a high stability, and the name is the benzene. Okay, for example, I give one example. For example, if I have one colorist here, is the chlorobenzene. Or if I have a methyl here, is methylbenzene or toluene. Here, as you see, is toluene, and it is a color. Next group is the alkyl halide or allyl halide. Alkyl halide, which alkyl group bind for the halogen. Halogen can be fluor, chlorine, bromine, can have the aryl halide, which has the aromatic bind to the hydrogen. For example, if I give example, CH3, methyl chloride, or phenylbromide. It's very easy and very nice, and as you see, halogen is very important for us. And the next group is the alcohol. Alcohol, when the OH group binds to the carbon with sp3. Okay, sp3 is the carbon which all of the bonds are the sigma. Okay, without pi bond. Okay, and the name is alkane without E plus O. For example, if I draw like this, it has 3 carbon. In the carbon number 1, we have an OH group, which is a propane. I cancel E and add O, propanol. Next group is the anode. Anode, which the OH group bind to the carbon with sp2, the same but with the sp2. OH bind to the carbon with sp2. sp2, as you know, the carbon which has it with a pi bond. Okay, for example, if I have a carbon with a pi bond and one OH in this group, it is an anode. Okay, in this situation we can say it's the mixing of the alkene and the alcohol, and the naming is very easy. Alkene has a high priority, and in the numbering, for example, if I have for example, this example, we have to start from this carbon, 1, 2, 3. Okay, it can be cis trans, we will study later in this examination. And in this situation, we can say 1 propane, 1 O. And the other group is the phenol group. Phenol group is easy. When the benzene group bind to the OH. In the name, we try to keep the phenol name. For example, if I add, for example, color here, we can say 2-chloro phenol. And in the aromatics, we will study also about position of ortho, meta, and para. As you see, all of these 3 groups related to hydroxyl group, and all of them has a hydroxyl group.